Okay, let's do an example. That's a steam turbine. Okay, here's a steam turbine. Okay, and so here, let's draw a steam turbine here. It's a simple steam turbine. We have a flow coming in here at 1 and a flow going out here at 2. And we're going to have some sort of shaft here. We're going to be producing some power. We're going to be analyzing. I'll just draw a big line. This green box is going to be our control volume that we're going to be looking at. Okay. So here's what the problem statement says. It says the mass flow rate of steam at steady state is 1.5 kilograms per second. So I know that mass flow rate of steam is going to be 1.5 kilograms per second. And the heat transfer to the environment is 8.5 kilowatts. So the Q dot out is equal to 8.5 kilowatts. So this problem didn't say it was adiabatic. They told me specifically there is some heat transfer. So one of my assumptions that I normally say is there, isn't there for this one. Okay? They want to know how much power do I produce if this is my situation. If state 1 is a pressure 1 is equal to 20 bar and temperature 1 is equal to 360 degrees Celsius, and my state 2 is pressure 2 is equal to 1 bar and it's a saturated vapor. So I know two things to set my states. I know enough information there to set my states. And we can figure out what we're going to be looking at. Now, I can look ahead and I can say, you know what? I'm going to have to know my enthalpies. I'm going to have to know what my enthalpy is at 1 and what my enthalpy is at 2. That's going to be needed for my equation looking ahead. So I'm going to go ahead and find those right now. And I'm going to go and turn to my document camera. And here we go. We're going to look at a pressure of 20 bars. 20 bars. Here's 20 bars right there. And it says I saturate 20 bars at 212.4. So that means that the state 1 is going to be a vapor. So I know that state 1 is a vapor. State 2 is a 1 bar and it's a saturated vapor. So I'm going to go up here to my 1 bar. Okay, here's my 1 bar. I'm going to read over what a saturated vapor is here. 2675.5. This is going to be 2675.5 kilojoules per kilogram. We're writing that on one note. No, you'll see it in a second. Now let me go and I have to go look for my vapor, 20 bar. Okay, 20 bar down here, 20 bar, and I'm looking at 360. 20 bar 360 is going to give me an enthalpy for this second one, for my first state, of 3159.3 kilojoules per kilogram. So that's where I'm setting the state. So I can put this all back into my equation, into my my data that I'm trying to arrive. So that's where all that chapter 3 stuff comes in. You should be able to set these two states very easily. They are easy lookups for you. Okay, now that I've set my state, I'm going to say, all right, I am going to write my first law. The change in energy of my control volume with respect to time is equal to Q dot minus W dot plus the summation of my mass flow rate N times my enthalpy N plus my kinetic energy N plus my potential energy N. Minus the summation of the mass flow rate exiting times my enthalpy exiting plus my kinetic energy exiting plus my potential energy exiting. Okay. Now we know this statement didn't say, and I didn't say anything about steady state, but I'm going to assume it's a steady state. And I'm going to assume that there's no kinetic or potential energy effects because it wasn't given to me in the problem statement. So now I'm down to this. I'm down to 0 is equal to Q dot minus W dot plus my mass flow rate times H1 minus H2. Okay, what do I have here? The problem statement gave me Q dot. The problem statement gave me M dot. And I looked up H1 and H2. My only unknown here is my W dot. Now my question for you is, how do I deal with Q dot? They said Q dot out was 8.5 kilowatts. What do I do for my equation? Do I put in 8.5 or do I put in negative 8.5? It's Q dot out. What I want you to do is solve this problem, put this into the solution here, and appropriately apply Q dot as you're solving for W dot, and find out what that answer is, and provide me the answer in kilowatts. Again, this is not a difficult problem, but there's a couple things we have to worry about. How to set the state, how to deal with Q dot, how to eliminate the all the variables in our equation. Okay. Good luck.